All right, guys, so let's get started by creating a new test project for our application layer. So in our test folder in our solution, we're going to create one I called mine hr.leavemanagement.application.unit test. So from start, it would be new project, and we're looking for an xUnit project template. And then we want to give it the name, of course, and it needs to be .NET 5. All right, so once you've done all of that, then you can jump over to NuGet, and we want to install Moq or Moq and Shouldly. So Moq is going to help us to create mocks of our persistence layer or repositories and other objects that are needed to simulate what our application or our handlers are really doing. And Shouldly is helping us to assert that this is what we expect from this kind of operation. Now, I've already gone ahead and set up a folder structure for you, and I think there are more interesting things for us to talk about than for you to sit down and watch me type. So I've gone ahead and prepared some of the assets beforehand, but as usual, we'll go through them slowly and together so that we can completely understand what is happening at each step. So in this project, we have two folders, at least for now. So we have one for leaf types, one for mocks. Mocks will be housing the mock repositories. Now you have two options, of course. You can have a file per mock repository, you can have one mock repository file and have multiple instances in there. That's up to you. Right now I'm only using one file, and well, we only have one test to run. So if you have 50 things or features that you need to run, or handlers, or features that you need to run unit tests against, then it would probably be better to just split them out into particular files per data set that you would want to have a mock repo for. So let us go into the mocks first. So I've already kind of gone through and set up a method in this file. So let's discuss it together. So I made this a public static class, and I'm calling it mock repositories. Once again, I could easily have been very specific and say something like mock leave type repository, right? As a matter of fact, I'm going to take my own suggestion and just do it this way. So we have this file particularly for mock leave type repository. Later on, when we come back, we have mock leave allocation repository, etc., etc. So mock leave type repository is a static class, and it has a static method in it. This method is designed, once again, public static, and notice that it is decorated with this keyword mock, which comes to us courtesy of the mock library, right? And it will allow us to mock any type of repository here. So I want a mock leaf type repository. I'm mocking the iLeaf type repository. And then I'm calling the method get leaf type repository. Now, this method is going to have a list of leaf type objects. You can be completely fictional with these. There's nothing to say that they must look like what would be in the database. There's nothing particular about it. It's just a list of objects similar to what we would expect from the database when dealing with the domain leaf type objects, right? So I just have 2. You could have 10, you could have 15, you could have 20, you could have more based on your scenario and what you need to test for. You may need more, you may need fewer than that, but that's up to you. So I'm only proceeding with 2. All right. Then we initialize our mock repo. So I'm going to say var mock repo is equal to new mock, and the type once again is iLeave type repository. So until we do all of this, you're going to be seeing a red line beside this method because it's saying it does not all paths return a value because we need to return the mock. So before we can return the mock, we need to set it up. So sample data is present. The new object of the mocked repository is present. So now we need to literally call mockrepo.setup. We use a lambda expression where it gives us access to the methods that would have been inside the original repo. So if we want to test the getAll method, or at least set up the getAll method, it means that when a test is calling this mock repo and we want to invoke a test against code that is using this getAll, it will pass in the mock repo, and then we're setting up the getAll method. So this is one block, right? So setup r lambda expression r.getAll, that's all in one block, and then dot returns the list of leaf types. So any code that gets the mock repo and is going to call the get all for this repository, the mock, which will be invoked in the test, will return that list of leaf types. That's what it will deal with. All right. So you're in complete control of your sample data. Kind of tedious to get up and started with, especially with the sample data, but it's all for a good cause. Now, the next one would be to set up what happens when we call the add method, right? So mock repo.setup, once again, that lambda block where we call the add method. So all of that is a block. And I'm going to just explain what's happening here. We're saying r.add. Now remember that the add method by default needs an object of type leaf type entity. All right, I'll just leave it on the screen, right? So we have to pass a leaf type entity into the add method. What we're doing here is that we're kind of doing an assertion that you can only call this method when an object of type leaf type is being passed in. Once again, this can be a dummy object. It just needs to be of type leaf type. It doesn't have to have all this data and anything special. All right. So if it is of type leaf type, then this method can be called and it returns async an object. So what we're going to do is do a delegate to say after getting the object of type leaf type, and then we have our lambda expression, our method block. Let me just move it to the next line so you can see it more clearly. Then we say leaf types, which is our list, dot add. So for the lifetime of the test, whenever somebody calls the add method and passes in that leaf type object, we're just going to add it to the list of leaf types and then return that particular leaf type. So that's just how the setup works. And then based on the scenario you're testing for, your setup may differ. So you notice that the get all setup looks, fairly different from the add setup. And then the delete one may look differently, and then the update one may look differently. So right now we're just setting up for add and get all, and then we go ahead and return that mock repo. So after returning it, that error would go away, and that is what this method is for. So after you've replicated all of that, you can just, I'm sure you were pausing and writing it down, but I hope you have a better understanding at least of how the mock helps us to simulate data without actually touching the database. Now let's jump over to our first unit test. Now this one is going to be in the queries folder. So I have leaf types, then I have commands and queries. All right, so the handlers that are doing queries will be tested inside the queries folder, and commands in the commands. So the first one that we have is the get leaf type list request handler test. All right, it's a mouthful, but at least nobody can make a mistake as to what is being tested inside of this file. You can have multiple tests, of course, but then in this scenario, we only need one test really for the get list handler. All right, now let me just walk you through what is happening within these first about 10 lines. So we know that we need auto mapper, and we know that we need a repository in order to interact with the handler, right? And I'm just going to jump down. I haven't finished writing the test yet. We're going to do that together, but I want to just demonstrate what happens when we try to instantiate our handler. We're getting an error. Why? Because the handler is expecting a parameter of type iLeaf type repository and another parameter of type iMapper. Now this is a unit test. We can't just inject them in. That's one. Two, we wouldn't want to inject it in. I mean, we probably could, but we wouldn't want to because we're dealing with mocks, right? This is a test. We don't want to inject in the real iLeaf type repository because that's going to talk to the database. We don't want our unit test to actually talk to the database. We just want to simulate it. So what I've done is initialize, or declared rather, two private fields, one for the mapper and one for our mock repo, right? So private read only mock of type iLeaf type repository, mock repo. Then we have our constructor. So in the constructor, once this test is invoked, we want to initialize our local mock repo to be equal to call the mock leaf type repository class dot get leaf type repository method. All right, so that now will do all of that setup and return the mock repo for use in this test. Now for the mapper, once again, we're not injecting anything. So we need this mapper to know of all the actual mapping configurations that exist in our application. So what we're going to do is initialize a mapper config object to be a new mapper configuration, and then we have a lambda expression here with our object block, within which we say lambda token dot add profile for the mapping profile. After we've set up the mapping profile and the configuration, then we can now just pass that in. So we say mapper is equal to mapper config dot create a new mapper using that configuration. So now our mapper here in our test really it's representative of the real mapper in the application. So our method below now has public async task get leave type list test. So we're specific now. What exactly are we testing for? We're testing for the method that gets the leave types list. It is decorated with this fact attribute because this is what's telling the application that this is a unit test. So this is just saying, hey, whatever happens here needs to be a fact. Whatever assertions here need to be passed. If they don't pass, then this test has failed. Now let us actually get into writing the handler, or the test rather. So we say var handler is equal to new, and then I'm instantiating the handler that I wish to test in this method. Notice the red lines because it requires our mock repo or some instance of an iLeave type repository. So mock repo gives us a mock object, but then I can get the actual quote unquote actual object through mock repo.object. Next up, we need our mapper. All right, that looks good. Next up, we want to actually test the method call. So I'm going to say var result is equal to handler.handle, right? Because every handler has that method called handle, and it requires a new object, or it requires the request object. So we need to pass in a new object of the, there we go. And I'm just going to take all of this off and use the insert, the using statement. There we go. So that we don't have all of that text. And then after that, it also needs a cancellation token, right? So cancellation token, or I can just pass in cancellation token dot none, right? So we can just pass that one in. Get the spelling right and include any missing references. There we go. So we're just saying call this. We're not passing any cancellation token in. We're passing in that new, object. So we don't necessarily have to mock this. So mock is really just for the data. All right. Now we can say result. And if you look at the data type for result, oh, well, we need to await this. Apologies. If you look at the data type for result, it is actually list. Yeah, there we go. So the data type for the result is a list of leave type DTO. So it's easy enough to do our if statements and say, okay, well, if the count is greater than 1, then this, or something like that, just to make sure that we got back more than 1, because it's the list. So we should get back 1 or more. But then at the end of the day, we can sit down and think of all sorts of scenarios and so on that we may get overwhelmed. So that's why we have the framework Shouldly to help us. So I can say result dot, but remember that this is really just a list. It thinks it's just a list. But I'm going to type should be of type because I want to make sure that I'm getting back the correct data type. The correct data type that we expect from our handler for this particular call would be the list. The data type would be list of leave type DTO. So I'm going to say, and don't mind the red lines for now. Let's just work through this part. Leave type DTO. All right. Now, when I do that, there is clearly a red line because should be of type. You've probably never seen that before. So if I control dot, you'll see using Shouldly. So that is where Shouldly comes into play. It helps us with our assertions, with our assumptions about what should happen. I'll go ahead and put in the using statement for the DTO also, but then that is the point of Shouldly. So I invoked the handler, I ran a command or ran an operation, got the result, and then I'm saying that the result should be of type leaf type DTO. So that's one assertion there. Let's see what else we have. We can say result dot and just start typing should, and we'll see all of the possible, right? All of these are possible things that we can assert, right? Should be null, should be in range, should be in order. All of these things are things you can check for. So I can say should be and say 2, because I know for my test data that they should, oh, sorry, I would more say result dot count should be. There we go. All right, so the should be is just tacked on to any other property or the object itself, and it allows you to check the assertion for whatever scenario you're expecting. So now that we've set that one up, let me right click the project and say run tests. And that will give us a test explorer, which will then run the test and show us what passed. All right, so that one passed for if it should be 2. Now I know I put 2, but let's say I said 5 and rerun this test. Now we're getting failures, and if I expand that just a bit, you'll see shouldly assertion should be 5 but was 2. So that means if something changed in my code and my assertion, I know my code is supposed to return 2 at all times, but then something changed. So let's say I didn't change the test. I know it's 2, right? But then if I put in another item, right? So this is where modifying the code comes in. And yes, this is all still testing, but once again, we're just talking about scenarios. So maternity, right? If I change the code, that should have returned 2 and should always return 2, and I introduce something, now it's returning 3. My unit test, just by running it, will now tell me when something changed. So let me just rerun that unit test. And my assertion is still 2, but then 3 came back. So right off the bat, I know that there's some bug in the handler that I am dealing with, all right, because something went wrong. So that is kind of what unit testing brings to the table. Now let's create our create leaf type command handler test. All right, so inside of the commands folder, you can go ahead and set that file up. And it's going to look fairly similar to the get leaf type. We have the same mock repository being used. We have the same initialization procedure being used. And then we have a test, which is decorated, of course, with the fact and the task where we say create leaf type. So we invoke the handler, which is the create leaf type command handler, passing it the objects as necessary, and then we have the result. So our result is going to come from awaiting handler.handle create leaf type command. And remember that our leaf type command to create requires a leaf type DTO. So that means we need some object here to pass in. Now you have 2 options. You can create the new object right here in this handler and use it. But then if you have multiple tests, you can just create an object of leaf type DTO and use that for multiple tests. So I'm going to use the second approach where I'm going to have my private read-only leaf type DTO, and then I'll initialize it in the constructor. Some people, after a while, they have so many assets being initialized that this constructor grows too large. What they would do is maybe farm it out to another method that they call like initial setup or initialize, and then they do all these initializations in there. And sometimes assets are actually shared across tests. So what they would do is farm it out to an entirely different file, like a class.setup, right? Leaf type test setup that will just go ahead and return all of the objects needed. So there are a number of ways, but these aren't big tests, so we just want to get the concept under our fingers before we think about abstracting it too much, right? So we have all of that set up, and we have our leaf type DTO that needs to be passed in. So oh, sorry, I'm getting this error because it's the create leaf type DTO. Apologies. So let me just fix that data type, and then we should be good to go. And there we go. All right, and of course no ID is in that one. All right, so let us see what we need to assert in this one. Well, for one, when we add a new leaf type to our mock repo, then the count should increase, right? Just the same way when we add it to a database, if there were 10, now there are 11. So remember in our mock repo, we had set up the add method that should take any type of leaf type and it should add it to the list, which means that if I was to call the list or to get all from the repo right after an add operation, then there should be one more file than there are now, one more record than there are at the time, right? So there are 3 now. Let me first update this assertion to say 3. And then I will call the mock repo. So I'm going to say var leaf types. I'm going to query the repo for how many. So of course we're doing the mock repo dot object dot, and then we can just get the get all. So when we invoke get all, we know exactly what we're getting. We're getting that list. Then I can do my result dot should be, and we know that we are returning the ID value. So after calling the create handler for leaf type, it should be of type int, right? So that's our first assertion. And then I'm going to also say that leaf types dot count dot should be, and I'm going to make sure that it says 4 because we know we're starting off with 3. Now after the call it should be 4. Now before I run the test, I'm just going to rename it to look a bit more useful, right? So create leaf type test. That's but then you can have multiple tests against create leaf types. You could have testing for what happens when it's invalid, testing for what happens when it's valid, testing for what happens when a value is a particular value and you have a business rule in there where it should behave this way or that way based on the nature of whatever is being passed in. There are so many scenarios. I can't sit down and think of every scenario, but I'm just giving you the framework upon which you can formulate your tests. So this test is an assertion that whenever a valid leaf type is added, this is the expected behavior. So I'm going to jump back over to our handler just so we can understand again the purpose of unit testing. So testing that we get back records, that's easy. Okay, yes, we have the mock repo. We're only querying the mock repo. The handler is supposed to do one thing anyway, which is return what's in the repo. That's fine. But then in a situation where we have multiple outcomes in our handler, we want to test for each outcome. And then you can probably break it down into the good test and the bad test. That's at your discretion, but you want to make sure that you have coverage for the potential outcomes. Because if business rules change, if a developer comes in and changes the if statement, even if accidentally, then one of the outcomes will change and you want to catch that as early as possible. So in our create leaf type command, remember that we're doing some validation here, right? So we validate the leaf type and then we throw an exception when it is not valid. Then if it is valid, we go through and we return the ID. So we've tested that already and we see we're adding the thing actually brings back more records if we were to check the repo. And that's good, but we need to test for what happens when bad data goes in to make sure that it is handled correctly according to our business rules. All right, so that's where we made the assertions. We assert that if I get an invalid request object with an invalid leaf type DTO, leaf type request DTO, leaf type DTO, sorry, that we should get an exception or we should get certain things in the response based on how you wrote your code. This is what should happen when this scenario is met. Notice also that because we're writing unit tests, you'll start seeing how many references and how many tests are passing for your code. So you can always know that you're in the green or you're in the amber, or well, you're either in the green or you're not in the green when it comes to the tests passing. So I'm going to jump back over to our test, and I have added another test for the invalid leaf type added. All right, so we have the same code where we set up our handler. right? And then once again, that is repeating. So what some people do and what I tend to do at times is move that repeating code up into being a private field and initialize it in the constructor. So you see, as the testing whole file grows, you may want to farm some parts out, because we don't want to have to do this every single time you have a test. You have to initialize. So it's the same command handler that we're going to be using with the same mock repo and the same mapper. So after setting up the mock repo and the mapper, we can just initialize our handler to get those objects. So then our test looks, well, we have one less line to worry about, right? So we just say underscore handler dot handle and move ahead. So in this new test, I am going to take my leaf type DTO and I'm going to make it invalid. So remember that we initialized it to have 15 days and that name, but then we know that what we're testing for. If a leaf type ever came over with this, then it should be invalid, right? So we're just going to make it invalid, and then I'm going to do something a little differently now. So we're testing for an exception, right? So I'm going to say validation exception ex is equal to await should. So we get a static class called should dot throw async validation exception, and then we open parenthesis, and you can open and close, and then inside of that you say async delegate lambda arrow, and then we're going to await the handler call passing in the DTO. So literally just this line we're putting inside of that should throw async method. Then at the end of it, we can test to say get all the leaf types. So we're going to go into the leaf types. Remember, we did that up here and we said that it should now be 4. So after an invalid operation, it should still be 3, right? So that's what we're testing for. We're making sure that this did not make it into our mock repo data set. And then I can also make sure that the exception should not be null. So this is my way of making sure that an exception was indeed thrown. So now that I've done all of that, and when you're testing, sometimes you get the failure. So when you get failures, it's either because you need to refine the test to make sure that you're testing the right thing, or you've written the test and you're testing the right thing and it's failing because your code is not passing the test. All right, so 2 parts to look out for. So now that I've done all of that, let's go ahead and run a new set of tests. And I'm getting all green lights everywhere. So the invalid leaf type added, all the assertions passed, which means that it correctly did not add it to the repo, and it threw the exception because the exception was not null. The valid one was added successfully, and then of course we retrieved the things in the repo properly. All right, so we can close that test explorer, and then we'll see the green ticks here, and then if we look back in our code, what was saying failed is now saying passing. All right, so you can see how many tests are making reference to this particular handle method in this command. So that's a quick and dirty overview of unit testing and how it can help us with our code coverage. I encourage you, of course, to write other tests for your other handlers and explore how the different scenarios can be tested for.